Okay, so what has happened here is that I have shown you this device. Has an aluminum ball at the top, has a aluminum rod that goes down through a rubber stopper. And this entire thing comes down to a point where it's actually got a clip, and then these leaves come out like this. Now, initially, when this thing is just sitting in the physics prep area and nothing's been done to it, etc., well, this entire thing is sitting there, and as most things in nature, it is sitting in a neutral condition. And as a result, if we call, we'll say positives are blue and negatives are red, okay? They're both positives and negatives all over this thing. And they're basically evenly distributed. If you've got 3, then you've got 3 of the other, and that keeps the whole thing neutral. And they're all over here. And down through the middle, and down here as well. And everything is in a neutral state. Now, when I bring in that rubber rod, got a little point on it, and I bring that into contact with this. Well, before I bring it into contact with that, this thing is covered with negative charges. Okay, I've rubbed those negative charges on from the rabbit's fur, and what I have all over this, negative charges. Now, there's some positive charges still on there, but the negative charges overwhelm the number of positive charges because there's so many more of them. Now, a couple things that happen. Well, first of all, in nature, negative is attracted to positive. And so as a result, right here, they don't like all the negatives go one place and all the positives go somewhere else. They're always kind of paired together. Over here, there's so many negatives that they're trying to get away from each other. Now, on that rubber rod, since it's not a very good conductor, they can't travel very easily on that. I may be overstating them being all over the entire rod. Probably they're just concentrated very heavily where I rub the rabbit's fur. And so then I bring that up, and there's all these extra negatives there, and there are some positives here, but the negatives that are there want to get away from the other negatives. So I bring them up and put them in contact with this ball up at the top here. And when I do that, all of a sudden, there's a whole mess of negative charges that are introduced right there. Now, unlike the rubber rod, where the negative charges can't run around very well because it's a poor conductor, this is aluminum. Aluminum is one of the best conductors that we have. Aluminum and copper, gold. There's a variety, but aluminum and copper are the ones that we primarily use because they're cheaper than the other materials. So I get all these extra negative charges here. Now, they don't want to be around each other. And so what ends up happening is that they distribute over the entire length of this aluminum setup. And now, suddenly, everything here is fixed with the exception of these 2 aluminum leaves, which are able to move because they're only connected right here. And as a result, when all of a sudden there are many more negative charges down here on either side than positive charges, these 2 leaves will spread apart because the negatives continue to try to get away from each other, and they try so hard that, in fact, they're able to push these 2 leaves apart. Now, I can do exactly the same thing, and what you will see is exactly the same thing with a glass rod and a piece of silk. Again, what I'm going to do is I'm going to rub, in this case, I'm rubbing positive charges off of the silk onto the glass rod. Now, don't ask me how I know they're positive, because I can't look at them and see plus signs, okay? But that's what's getting rubbed off of the silk. Now, when I bring them up here, again, you can't see anything with the rod itself, but if I bring this device back in, and I'm going to rub those charges off of this, and hopefully you can see that the leaves are spreading apart. And all the rationale that I just discussed back there for the negative charges, if you just make all those charges on the rod blue instead of red, then you got exactly the same situation, but for positive, so there's an excess of positive charges. And again, here I've wiped some of those charges off. If I ground this thing by touching the top, you should see the leaves move closer together, and that's because I've neutralized the whole thing by taking the extra positive charges off. Other things that we can do and discuss as far as this goes, I have here a small green balloon, and I can rub that on my head, and I can put it on the board, and it stays on the board. Now, why does it stay on the board? What did I do? Well, we gradually going down the board. But initially, it stuck to the board. Now, what's going on there? Well, if I draw a picture, if this is the wall, and that wall is sitting there, and again, it's neutral. And so as it sits there, there's an equal distribution of positive and negative charges. Now, when I rub that rubber balloon on my head, that stuck better this time. What I've done is I've rubbed a bunch of negative charges off of my hair, just like negative charges went off of the rabbit's fur, and I've put them onto that balloon. And the balloon strangely reshaped itself, so I'm not sure what's going on there. But what I've done is I've introduced a balloon here, and that balloon has lots and lots of negative charges. Now, those negative charges are trying to get away from the other negative charges, and as soon as I touch that to the wall, they have a path by which they can escape. Right? They can run along here and get off. And so they start to do that. And in the process of moving and trying to escape from the balloon, they are moving onto the wall. And so there's travel of electrons going back into the wall right now. Right? And as a result of that, it holds the balloon there. The fact that they are moving along through there is a greater force from the electrons moving than there is the force of gravity on the balloon. Of course, we know balloons doesn't weigh much, there's not a whole lot of gravity on that. So the electrical force that exists here is enough to keep this attached to the wall for quite some time. First time, not so much. This time, I did a better job of rolling it on my head. So, there you go.